Have you ever trained a machine learning model only to find that applying it to a large dataset feels like watching paint dry? It can be incredibly frustrating. If you're facing this issue, you're in the right place. Today, we're going to explore how to efficiently apply your trained Scikit-Learn model on a big dataset using PySpark. I completely understand your concern. Waiting for predictions on a massive dataset can feel like an eternity. You're definitely not alone in this struggle. Many data scientists encounter similar challenges when transitioning from Python to PySpark. Let's dive into the specific situation at hand. One user recently asked, "I trained a random forest algorithm with Python and want to apply it on a big dataset with PySpark. I loaded my trained model and added a prediction column, but it takes so much time to run. Is there a more efficient way to do this without using Spark ML? Sound familiar? Let's tackle this together." So, what could be causing the slowdown? When applying a model to a large dataset, using user-defined functions can lead to performance bottlenecks. PySpark is designed for distributed computing, and we need to leverage that power effectively. Let's break it down step by step. And stick around. I have a game-changing tip at the end that will help you speed up your predictions significantly. To improve the efficiency of applying the trained model, the user should consider using the Spark's built-in capabilities for parallel processing. Instead of using a user-defined function, we can leverage the Pandas UDF feature. Next, the user should import the necessary libraries. This includes importing the Pandas UDF decorator from PySpark and the required types. Now, the user can define the Pandas UDF. This function will take a Pandas series as input and return the predictions from the trained model. After defining the UDF, the user can apply it directly to the Spark DataFrame. This will allow Spark to handle the data in parallel, significantly speeding up the prediction process. Finally, the user should verify the results. They can do this by showing a few rows of the new data frame to ensure the predictions have been added correctly. Fun fact, the first machine learning models took hours to train and predict. Now with tools like PySpark, we can do it in minutes if we use them wisely. Now let's look at the answers provided by other users. An alternative approach shared by another user suggests using the map partitions or 4H partition method on RDDs instead of applying a user-defined function for each row. This method improves efficiency by ensuring the Scikit-Learn model is read only once per partition. This method avoids shuffling and significantly speeds up the prediction process. For more details, you can check the provided link for a thorough explanation. That's all for that response. Let's see what someone else had to say. An alternative approach suggests using broadcast variables to improve performance when applying your Scikit-Learn random forest model in PySpark. This method helps to cache a read-only copy of the model on each machine, reducing the overhead of frequent pickling and unpickling during task dispatch. Let's move forward and look at another answer. An alternative approach suggested by a user is to utilize Pandas UDF, which was introduced in Spark version 2.3. This method enhances processing speed and enables distributed computation. It leverages PyArrow, a Python implementation of Apache Arrow, for efficient in-memory computation. Here's the tip I promised. Always profile your Spark jobs to identify bottlenecks. This simple habit can save you hours of frustration and improve your workflow. And there you have it. By using the right methods and configurations, you can apply your Scikit-Learn model to large datasets much more efficiently. If you found this video helpful, don't forget to subscribe for more tips and stay tuned for our next video where we dive deeper into optimizing your data workflows.